All right, in this video for 10.7, we're going to look at some segment relationships where we have tangent and what we call secant segments. To start things off, we're going to take a look at where we have two chords inside of a circle intersecting. Turns out if they do intersect and you look at their individual pieces, when you multiply those lengths together, you get an equal value. So for example, in this circle here, if you look at segment AC and ED, those are chords of our circle. Be really careful not to assume that B is the center. In fact, it kind of looks like it's not. What this theorem is saying is if you look at the parts of AC, so that would be AB and BC, if you multiply those together, you will get the same result as if you were to multiply EB and BD. So here's a nice little equation. So AB times BC equals EB times BD. So part times part equals part times part. The reason why this is true is we're not doing a whole lot of proofs this semester, but if we were, we would actually connect A to E and D to C and prove that we have similar triangles, like from chapter 7, and then use scale factor, and you're going to get this equation. So this is when I have two chords intersecting. Now we want to define something else. This is called a secant line. So this is going to be a line or a line segment that intersects a circle at exactly two different points. So in this diagram here, line A would be what we call a secant line, whereas line B, that's something we saw last section, that would be a tangent line. So it appears it only hits at one single point. So one theorem we have about secant and tangent segments, whenever they intersect outside of a circle, either a secant with a secant or a secant with a tangent, the product of their exterior length with their entire length, those products are always going to be equal. So for example, this diagram here on the left, I've got a secant segment AC and a secant segment AE. Both of those segments meet at point A. And on the right-hand side, I have a tangent segment, JK, and then a secant segment, JM. So in both cases, I have either a secant intersecting a secant outside of the circle or a secant intersecting a tangent. So the equations that we could come up with would look like AB times AC, so the outside part of AC times the entire thing, equals AD times AE. So outside times whole equals outside times whole. For the tangent intersecting the secant, it's basically the same idea. The only difference is with a tangent, the outside is the whole part. So I'm going to do the outside, JK, times the whole part, also JK, equals outside times whole, so JL times JM. So the tricky part with a lot of the diagrams, they're going to throw some numbers at you. You just want to really focus on the pattern, which is outside times whole equals outside times whole. So the big takeaways for getting started on those Schoology questions, these two equations here with secants intersecting each other, or a secant with a tangent, and with two chords meeting, it's part times part equals part times part. That should do it for 10.7.